Okay, Assalamu alaikum students. So today we are going to see October November 2024 IGCSE paper 4 variant 3. This is a 1 hour 15 minutes paper. So let's take out your calculators. Please take out your brains as well. And let's zoom in a bit. Yeah, let's start with this. State the difference between a scalar and a vector quantity. बेटा scalar और vector quantity में क्या difference होता है? Do you remember? Scalar quantities, or let me lighten this. Scalar quantities, a scalar quantity only has a magnitude. Only has a magnitude. However, vector quantities, vector quantities have a magnitude and direction both. स्केलर क्वांटिटीज के पास बेटा क्या होता है? सिर्फ मैग्नीट्यूड. हाउएवर वेक्टर क्वांटिटीज हैव अ मैग्नीट्यूड एंड डायरेक्शन बोथ. सिंपल. लेट्स फर्दर मूव अहेड. अब हम आते हैं सेकंड पार्ट पे. डिफाइन मोमेंटम. वेरी इजी डेफिनेशन. प्रोडक्ट ऑफ मास एंड velocity. That is the definition of momentum. Product of mass and velocity is your momentum. Let's further move ahead. आगे बढ़ते हैं. ठीक है. Now let's read out part B. This is a good part. A test car crashes into a barrier to test the safety features. The test car has a total mass of 950 kg. It is moving with a constant velocity. Okay, it is moving with a constant velocity from time t is equal to 0 till 4 seconds. At time t is equal to 4 seconds, the car hits the barrier. Perfect. During the test crash, the resultant force acting on the car is this. The car takes 1.5 seconds to come to rest. Okay, so the final speed of the car is this. The deceleration is uniform, that is constant. What is the initial velocity of the car? You have to calculate the initial velocity of the car. How will you do that? Very easy. First of all, we will say resultant force is equals to change in momentum over change in time. Beta, what is your resultant force? 27,000 Newton. How will you calculate the change in momentum? Final momentum minus initial momentum divided by the change in time. What is the change in time? 1.5 seconds. Multiply to the left side. 27,000 into 1.5 is equals to final momentum minus initial momentum. Can you calculate this? 27,000 into 1.5. This comes out to be what? बेटा ये क्या आ जाएगा? 40,500 is equals to your final momentum minus initial momentum. Now बच्चों, can you realize that the final velocity is 0? Why? Because you are coming to rest. That means your final momentum is 0. 40500 is equals to negative of initial momentum, that is mass into the initial velocity. Do you have the mass? Yes, 950. So yeah, 40500 is equals to negative 950 into the velocity, that is you. 40500 divided by 950 is equals to your velocity. Can you calculate the velocity? Yes, geniuses. The velocity comes out to be negative 43 meters per second. We will ignore the negative sign. Just write the velocity, that is 43 meters per second. You don't need to write negative in velocity. The negative sign just indicates direction. Beta, can you realize that this car was moving towards the left? And left side vectors are negative, right side vectors are positive. That's why this velocity was considered to be negative here. So we ignore the negative sign, just write the final answer as 43. Simple. Let's further move ahead. On figure 1.2, okay. Sketch a speed time graph to show the motion of the car from time t is equal to 0 until the car becomes stationary. Perfect. But first of all, we have to read this entire question again. Can you realize from time t is equals to 0 for 4 seconds, The car travels at constant velocity. That means what? You will draw a horizontal line from t is equals to 0 till t is equals to 4 seconds, like this. This is your horizontal line from t is equals to 0 till t is equals to 4 seconds, somewhat like this. Then what will you do? If you realize at t is equals to 4 seconds, the car hits the barrier and decelerates uniformly. मतलब आपकी deceleration क्या है? Constant until you reach a velocity of 0. Beta, you have a constant deceleration. Now, do you remember that the gradient of speed time graph is equals to acceleration? If you have a constant deceleration, that means your gradient is negative and constant. If your gradient is negative and constant, which type of a line will you draw? Downward sloping line like this. Simple as that, nothing complicated here. Let's further move ahead. Describe an experiment to determine the spring constant of a spring. Okay, so you have to somehow determine the spring constant K of a spring. State the apparatus that you will need, details of how to take the measurements, and how to calculate the spring constant. You may draw a label diagram. So let's start with it. First of all, you will take a spring and attach it to a fixed end. बेटा इस तरह आपने स्प्रिंग लेना है और फिक्स्ड एंड से अटैच कर देना है. लेट्स से दिस इज योर फिक्स्ड एंड. परफेक्ट. एंड देन व्हाट डू यू डू फर्दर? आप यहाँ पे एक पॉइंटर भी लगा दो. लेट्स से दिस इज योर पॉइंटर एंड let's say this is your meter rule. Yep. Let's say this is your meter rule. This is your initial length of the spring L naught. You can say L naught is your initial length of the spring. Perfect. This is your meter rule. Label this as well. Now, what will you do further? बेटा अब आपने इस स्प्रिंग से मास या फिर वेट अटैच करना है. सर हाउ विल वी डू दैट? लेट्स से दिस इज योर फिक्स्ड एंड let's say this is your spring. Now you have attached a weight to it. Let's say like this. This is your weight W. Let's say this is your pointer attached here. Perfect. Make a meter rule as well. Like this. This is your meter rule. Using the meter rule, you will measure the final length L1. L1 is the final length of the spring. But sir, how are we going to calculate this small little spring constant? Sir, हमने तो spring constant निकालना है. How will we calculate this? First of all, you will start writing by saying measure the weight of the block, this block. Measure the weight of this block using a force meter. Since you have to tell everything, so you can say measure the weight of the block using a force meter. Perfect. Then you will say measure the initial length of the spring L naught and final length of the spring. Final length of the spring L1 using a meter rule. Further, what will you say? Calculate the extension by subtracting initial length from the final length. Initial length L naught from final length L1. Now, you can quickly apply the formula F is equals to KE to calculate the spring constant. But that would be a very bad approach. बेटा अगर यहाँ पे मैं लिख दूं apply F is equals to KE to calculate spring constant, this will be a bad approach. Why? Why will this be a bad approach? Because I am basing my entire calculation on one reading of weight and on one reading of extension. बेटा मैं अपनी पूरी की पूरी कैलकुलेशन बेस कर रहा हूं ऑन वन रीडिंग ऑफ फोर्स एंड वन रीडिंग ऑफ एक्सटेंशन. दैट इज नॉट अ गुड वे टू डू फिजिक्स. सो व्हाट विल यू से? You will say repeat the experiment. Repeat the experiment with multiple, yeah, with various. Repeat the experiment with different masses and plot a graph of force versus extension. Repeat the experiment with various, yeah, different masses, or you can say weights as well, and plot a graph and plot a graph of load versus extension. Now, if you really want that A star, if you really want that distinction, you show the graph as well. Because you have this blank space, you can write here. So you show the graph as well. You can say this is the force on the y-axis, extension on the x-axis. And last point, you can say the gradient of force versus extension graph is equal to the spring constant. This is how you logically plan out and write for an experiment based question. Simple. Let's further move ahead. Figure 2.1 shows a baby in a baby bouncer. Perfect. The baby bouncer consists of a holder suspended from a spring. Perfect. The baby pushes his feet on the ground and bounces gently up and down. Perfect. Baby gently up and down bounce कर रहे हैं. Two springs Q and R are tested to determine their spring constant. Each spring is tested up to its limit of proportionality. Define limit of proportionality. Limit of proportionality क्या होती है बेटा? Limit of proportionality is the maximum force up to which extension is directly proportional to the load. So you can say limit of proportionality is the maximum force until, yeah, up till, you can say anything, maximum force up to which extension is directly proportional to the load. Simple as that, nothing complicated here. Let's further move ahead. Table 2.1 shows the results of the test. Okay, so table 2.1 shows the results of the test. The total weight of the baby and the holder is 120 Newton. Achha ji, total weight of the baby and the holder is 120 Newton. Calculate the extension of each spring for this weight. You have to calculate the extension for each spring How will you do that? Let's first of all do it for Q. F is equals to KE. Force क्या है? 120. K हमें नहीं पता. Oh, sorry. We know the K. We know the K for Q. What is the spring constant for K? What is the spring constant K for Q? 7.8. Can you calculate the extension of Q? Yes. 120 divided by 7.8. What does your extension comes out to be? 120 divided by 7.8. Your extension comes out to be what? 15.4 centimeter is your extension of Q. Can you calculate the extension of R? Yes, F is equals to KE. What is your force? 120. K हमें पता है 1.1. Can you calculate the extension here as well? 120 divided by 1.1 is your extension of R. What does that comes out to be? 120 divided by 1.1. This comes out to be 109.1 centimeters. So you can say 109 centimeters, simple as that. You can write your answer till 3 significant figures or 2 significant figures, doesn't matter. It's up to you. Perfect. Now let's further move ahead. The unstretched length of each spring is 25 centimeter. Okay. So what is unstretched length? Do you guys remember? बेटा अनस्ट्रेच लेंथ क्या हुआ करती थी? डू यू रिमेंबर व्हाट इज अनस्ट्रेच लेंथ? हाँ जी, डू यू गाइस रिमेंबर? अनस्ट्रेच लेंथ इज बेसिकली द लेंथ of the spring when no force is applied. Unstretched length is basically the length of the spring when no force is applied. Okay. And here I would like to introduce an other term that is known as the total length of the spring. बेटा total length of the spring क्या होती है? हाँ जी. Does anyone recall this from my lectures? What is the total length of the spring? Sum of unstretched length and extension. Sum of unstretched length plus extension. Simple as that, nothing complicated. The total length LT is equals to what? L naught plus extension. Simple as that, nothing complicated. Always remember this is a golden rule. Okay, total length of a spring is equals to what? Unstretched length plus extension. Simple as that, nothing complicated here. Now your unstretched length L naught is what? 25 centimeter. State and explain which spring would be more suitable for the baby bouncer in figure 2.1. अच्छा जी, हमने बताना है कौन सा स्प्रिंग मोर सूटेबल होगा. So let's first of all see. Can you realize spring Q की extension क्या थी? 15.4 centimeter. Can you calculate the total length for spring Q? L naught plus extension. L naught क्या है भाई? 25 centimeter plus extension क्या है? What is the, one second, extension of Q is 15.4 centimeter. This comes out to be what? 40.4 centimeter is your total length of spring Q. If you come to the top side, can you realize is बच्चे की, the baby has a total length of what? 100. The remaining length that we have for the spring. बेटा स्प्रिंग के लिए कितनी जगह है हमारे पास? The baby is already of 100 centimeter. How much length do you have for the spring? Approximately 40 centimeter. And the length of a spring Q is also approximately 40 centimeter. Yeah. So spring Q seems to be a justifiable option because the length that we have for a spring is 40 centimeter and the total length of the spring is also 40 centimeter. If you do this for R, can you calculate the total length of R? L naught plus extension. L naught क्या है भाई? 25. Extension क्या है यहाँ पे? 109. Can you see this is way larger? This is 25 plus 109. This comes out to be 134 centimeter. बेटा अगर आप स्प्रिंग आर लगाते हो तो देखो किस तरह की डायग्राम बन जाएगी. 134 सेंटीमीटर का स्प्रिंग होगा. 1 सेकेंड. Let me draw it here on the side. If you use a spring R, your spring will be of 134 centimeter और आपका baby ऐसे नीचे आ रहा होगा. It will get crushed by the ground. So you don't want such a large spring. You want a spring that approximately has a total length of 40 centimeter. You can write it here. Spring Q will be a better choice. And what is the explanation for that? Spring Q better choice क्यों है बेटा? Because the extension of Q is of the right length to allow the baby to reach the floor with feet. So you can say Q is the right choice because the total length, yeah, the extension you can say of Q is of right length, is of right length to allow the baby's feet to touch the floor, to touch the floor. Easy peasy, lemon squeezy. Let's further move ahead, beta. अब आगे क्या लिखा हुआ है? Figure 3.1 shows a portable shower used on a campsite. The bag is filled with water. The water is heated using infrared radiation from the sun. अच्छा जी, ये जो बैग है उसको हम हीट कर रहे हैं using infrared radiation from the sun, like this, like this, like this, like this. Simple. Explain why the shower bag is painted black. हमने बताना है why the shower bag is painted black. What will you say? Black is a good absorber of radiation. Black is a good absorber of radiation. Simple as that. Nothing complicated here. Explain a disadvantage of radiation from the sun being the only source to heat the water. बेटा disadvantage क्या होगा of using only the sun for heating? हाँ जी, इसका disadvantage क्या होगा? Sun does not appear at night. तो रात को you cannot warm up the water. There is no sun at night, so you cannot warm up the water at night. So yeah, the bag is filled with water, the water is heated. So you can say there is no sun at night. So you cannot, so the bag cannot, so the bag cannot warm water at night. Simple. Let's further move ahead. Solar energy is a renewable energy source. State two other renewable energy sources. भाई दो other renewable energy sources क्या क्या हो सकती हैं? Hydroelectric. You can also say tidal. What else can you say, beta? You can also say solar energy. You can also say wind energy. और कौन सी एनर्जी यहाँ पे कह सकते हो? हाँ जी, सोलर कह दिया, विंड कह दिया. What else can you say? You can say geothermal energy. You can also say. Simple. Let's further move ahead. During the day, the sun rises on the shower bag, and some of the energy in the infrared radiation from the sun transfers to the thermal energy of the water. Perfect. The water absorbs 60% of the energy. मतलब sun से, like let's say this is your sun. Let's say this is your sun. This is your small little cute bag, black bag. Whatever energy is coming from the sun, only 60% of that is getting absorbed by the black bag. Okay. The temperature of the water rises from 10 degrees centigrade to 43 degrees centigrade. This is the initial temperature. This is the final temperature. The mass of the water bag is this. The specific heat capacity of the water is this. Perfect. C M. You have to calculate the energy incident on the shower bag during the day. Show your working. Perfect. First of all, let's apply Q is equals to MC delta T. What is your mass of water? 40. What is your specific heat capacity of water? 4200. What is your change in temperature of water? Final temperature, that is 43, minus initial temperature, that is 10. Can you calculate the energy? 40 into 4200 into 33. Your answer comes out to be what? 5.544, 10 raised to the power of 6 joules. Beta, this is the energy that is being absorbed by what? This is the energy that is being absorbed by the black bag. You can say this is what? Your energy output. You have to calculate what? The energy incident on the shower bag. That is energy input. Beta, you have to somehow calculate energy input. How will you do that? Efficiency is equals to energy output divided by energy input into 100. What is your efficiency? 60%. Output क्या है बेटा? 5.544 10 is the power of 6 divided by energy input multiplied by 100. Can you calculate the energy input? Yeah, surely. Take energy input to the left side. Energy input is equals to 5.544 10 is the power of 6 into 100 divided by 60. Can you calculate the energy input? Hanji. 5.544 10 raised to the power of 6 into 100 divided by 60. Your energy input comes out to be what? 9.24 10 raised to the power of 6 joules. If you want to round it off till two significant figures, it will become 9.2 10 raised to the power of 6 joules. Simple as that. This is your answer. Nothing complicated here. Let's further move ahead बेटा. आगे बढ़ते हैं next सवाल की तरफ. Okay. Figure 4.1 shows a ray of light as it enters the side of a plastic block. The ray of light passes from air into plastic. Perfect. Ray of light क्या कर रही है? Air से plastic की तरफ जा रही है. State how the speed, wavelength, and frequency of the wave in the plastic block compares with the value in air. Okay. So air is a less dense material. Plastic is a more dense material. What happens as you go from less dense to more dense material? What happens as you go from less dense to more dense material, or what happens as you are undergoing refraction? Your speed decreases. And V is equals to F lambda. If your speed decreases, your wavelength will also decrease. What will happen to the frequency? The frequency remains same during refraction, or whenever you change a medium, your frequency remains same. Simple as that. Nothing complicated here. आगे बढ़ते हैं. Show that the refractive index of plastic is 1.4. Can you realize plastic is the second medium यहाँ पे? हाँ जी, plastic क्या है? Second medium है. How do you calculate the refractive index of second medium? Sin I over sin R. What is sin I? 45. What is sin R? 30. Refractive index will become sine of 45 divided by sine of 30. What does your refractive index comes out to be? Sine of 45 divided by sine of 30. Your refractive index comes out to be what? 1.4. Simple as that. You can write it here. Refractive index is 1.4. This is the refractive index of plastic. Simple as that. Now you have to calculate the critical angle of plastic. How will you do that? Do you remember that we have studied this formula? A refractive index is equals to 1 over sine of critical angle. Refractive index है 1.4 is equals to 1 over sine of critical angle. Sine of critical angle is equals to 1 over 1.4. Can you calculate critical angle? Critical angle C is sine inverse 1 over 1.4. What does this answer comes out to be? Sine inverse 1 divided by 1.4. This comes out to be 46 degrees as your answer. This is your critical angle. Easy peasy, lemon squeezy. Let's further move ahead. Figure 4.2 shows the same plastic as an A used to make an optical fiber. Okay. A ray of light is passing through the optical fiber. Carefully continue the ray of light until it reaches the other end of the optical fiber. तो बेटा हम क्या करेंगे? We have to carefully complete this ray until it reaches the end of the fiber. Do you remember in an optical fiber cable क्या होता था? कौन सा प्रोसेस होता था? Total internal reflection. In an optical fiber cable क्या होता था बेटा? Total internal reflection. Simple as that. So let's say you have this ray. This will get hit here. This is the normal. Reflected back. Total internal reflection perform हो रही है बेटा. Then again, this is the normal. And again, it will get reflected in a way that it passes through the tube. Like this. This is your angle of incidence. This is your angle of reflection. This is your angle of incidence. This is your angle of reflection. Simple. You can mark it in a better way like this. Simple. State two uses of optical fiber cables. Optical fiber cables बेटा कहाँ कहाँ use होती हैं? In internet transmissions and in cable TV. Optical fiber cables are used in internet transmissions and in cable TV. Simple as that. Nothing complicated here. आगे बढ़ते हैं बेटा. Let's further move ahead. Figure 5.1 shows a metal sphere S. The sphere has been charged with a negative charge. ठीक है, sphere के ऊपर negative charge. There is an electric field around sphere S. Perfect. On figure 5.1, draw four field lines to show the pattern of the field and indicate the direction of the field line with the arrows on the line. तो बेटा नेगेटिव चार्ज के अक्रॉस इलेक्ट्रिक फील्ड किस तरह होती थी? इनटू द चार्ज, लाइक दिस. In a negative charge, the electric field lines are pointing into the charge. Like this. You only have to draw four field lines, so you can erase this one. Erase this one. Figure 5.2 shows a position X next to sphere S. Okay. Figure 5.2 shows a position X next to sphere X. A small negatively charged particle is placed at position X. Okay, so we have a negatively charged particle here. State the direction of the force on the negatively charged particle at X due to the electric field around sphere S. Okay, what will happen to the direction of force on the negatively charged particle at X due to the electric field around sphere S? Hanji, the direction of force will be away. Yeah, towards the left. Why? Because this is a negative charge as well. This is a negative charge as well. Like charges. बेटा like charges क्या करते हैं? हमेशा repel. So what will you say? What will be the direction of the force on the negatively charged particle X? Away from sphere S. The direction of its force on the negatively charged particle will be away from sphere S. Simple as that. Nothing complicated here. Easy peasy, or you can say towards the left as well. Simple. The negatively charged particle at X is released from rest. Perfect. Describe the motion of the small negatively charged particle due to the electric field around it. Okay, you have to describe the motion of the small negatively charged particle due to the electric field around sphere X. What will you say? बेटा आपके नेगेटिवली चार्ज पार्टिकल को क्या होगा? It will accelerate or move away from the center of the sphere. You can say it accelerates or moves away from the center of the negatively charged sphere S. From the center of the negatively charged sphere S. Simple. Let's further move ahead. आगे बढ़ते हैं बेटा. क्या लिखा हुआ है? Figure 5.3 shows a sphere S being sprayed. Sphere S is negatively charged as the paint particle exit the wide nozzle of the paint sphere. They become charged with a positive charge. Okay, so all of these are positively charged. ठीक हो गया. ये सारे positively charged हैं बेटा. Okay, okay, okay. Explain why the paint particles spread out when they leave the nozzle. भाई पेंट पार्टिकल्स स्प्रेड आउट क्यों करते हैं व्हेन दे लीव द नोजल? Because paint particles are positively charged, or you can say they are like charges. Like charges spread away because like charges repel. Like charges एक दूसरे से repel करते हैं, hence they spread away because like charges repel each other, repel each other. Simple as that. The sphere can be painted by hand using a paintbrush. अच्छा जी, sphere को हम paint कर सकते हैं using a paintbrush. Suggest and explain one advantage to using a charge paint from a spray gun to a paint sphere S. ठीक है बेटा, हमने बताना है एक एडवांटेज ऑफ यूजिंग द चार्ज पेंट फ्रॉम अ स्प्रे गन टू पेंट स्फेयर एस. एडवांटेज क्या होगा? व्हाट विल बी द एडवांटेज? इवन कोटिंग ऑफ द पेंट. व्हाट विल बी एन एडवांटेज? इवन कोटिंग ऑफ द पेंट, या फिर कह सकते हो कि लेस स्पेलेज ऑफ द पेंट, या कह सकते हो कि लेस clumping of the paint particles. You can say more even coat of the paint, less clumping of the paint particles. And what will be the explanation for that? Because positive particles, yeah, positive paint particles are attracted towards the negative sphere as they spread out. So you can say more even coating of paint as, what will be your explanation? As positively charged paint particles are attracted equally towards all parts of the negative sphere, of the negatively charged sphere. Simple, easy peasy lemon squeezy. Let's further move ahead. क्या लिखा हुआ है बेटा? A car windscreen. Okay, what has happened to this mouse? Okay. A car windscreen is covered in condensation. Okay. A car windscreen is covered in condensation, small droplets of water. Thermal energy is used to remove the droplets of water. The thermal energy is provided by three resistors on the windscreen. Figure 6.1 shows two possible circuits for the three resistors. The three resistors are identical. Perfect. Describe two advantages of using circuit B. What are two advantages of using circuit B? Beta, can you realize circuit B may, even if one resistor malfunctions, the circuit keeps on working because circuit B is a parallel circuit. What is another advantage of circuit B? All the resistors get a higher voltage of 12 volts. So these are the two advantages of circuit B. You can write it here. You can say in circuit B, even if one resistor fails, the circuit keeps on working. Even if one resistor fails, the circuit keeps on working. What will be the second advantage beta? Second advantage of circuit B क्या हो जाएगा? The second advantage of circuit B will be that each resistor gets the full voltage of 12 volts. Each resistor gets the full voltage of 12 volts. Simple. Describe in terms of water particles the process by which water droplets are removed from the car's windscreen using the heater. तो बेटा क्या होता है? The car's windscreen provides heat to the water droplets. The car's windscreen provides heat to the water droplets. This causes the kinetic energy of the water molecules to increase. As the kinetic energy of the water molecules increases, what will happen? The molecules with greater kinetic energy will escape from the surface, and this is how water is removed from the windscreen using the heater. So, how will you phrase this answer? Beta, how will you phrase this answer? You will humbly say that the the heater provides thermal energy to the water droplets, to the water droplets. What will happen? This causes the kinetic energy of the water droplets to increase. And this causes the kinetic energy of water droplets to increase. This causes kinetic energy of water droplets to increase. What will you further say, Anji? The more energetic water molecules escape, the more energetic water molecules escape from the windscreen. Yeah, escape from the surface of the windscreen. The more energetic water molecules escape from the surface of the windscreen. Simple as that. This is how water is removed from the windscreen. Let's further move ahead. I think we are taking very long for this paper. Figure 6.2 shows a circuit containing two resistors P and Q. The circuit is powered by a 12-volt battery. Perfect. Calculate the current in resistor Q. You have to calculate the current in resistor Q. This is 12 volts. Resistance is 70. Can you calculate the current? V is equals to IR. वोल्टेज 12 है, करंट निकालना है, रेजिस्टेंस 70 है. कैन यू कैलकुलेट द करंट? यस, 12 डिवाइडेड बाय 70. करंट क्या आ जाएगा बेटा? हाँ जी, व्हाट डज योर करंट कम्स आउट टू बी? 12 divided by 70. The current comes out to be 0.17 ampere. 0.17 ampere is your current. Simple as that. Calculate the energy transferred electrically when the current calculated in B part 1 is present in the resistor for 5 minutes. How will you do that? Energy is equals to current V time. Current क्या है? 0.17. Voltage क्या है? 12. Time क्या है? 5 minutes. 5 into 1 second in each minute. Can you calculate the energy by 1 7 into 12 into 5 into 60? This comes out to be what? 612 joules is your energy, or you can say 610 joules if you want to round it off till two significant figures. Further move ahead. Energy is transferred from the battery by electrical current. State the energy stored in the battery. Always remember the battery stores chemical energy. Always remember that. Calculate the total resistance of the circuit. How will you calculate the total resistance of the circuit? There are two resistors in parallel. 1 over 90 plus 1 over 70 is equals to 1 over RT. Can you calculate the total resistance? 1 over 90 plus 1 over 70 is equals to what? 8 over 315 is equals to 1 over RT. Can you calculate the total resistance? Yes, 315 over 8. 1 divided by answer. Total resistance comes out to be 39 ohms. Simple as that. Nothing complicated here. You can further write here 39 ohms is your total resistance. Easy peasy, lemon squeezy. आगे बढ़ते हैं. Figure 7.1 shows a barrier at the entrance of a car walk. The wooden barrier has a weight of 60 Newton which acts through the center of gravity at the position shown in figure 7.1. ठीक है भाई, ये weight है जो downward act कर रहा है. Initially, the wooden barrier is horizontal. What does this mean? This basically means anti-clockwise moment is equals to the clockwise moment. Using figure 7.1, calculate the clockwise moment of the weight of the wooden bar about the pivot. So you have to calculate the clockwise moment due to this 60 Newton ka weight. So the 60 Newton is acting downward. Distance from the pivot is 1.7. Can you calculate the moment? 60 into 1.7. What does your clockwise moment comes out to be? हाँ जी, clockwise moment क्या आ जाता है? 60 into 1.7. This comes out to be 102 Newton meter is your clockwise moment. You can write here. The wooden barrier is in equilibrium. That means anti-clockwise moment is equal to clockwise moment. The mass of the soft iron bar is 23 kg. Okay. ये जो सॉफ्ट आयरन बार लगा हुआ है बेटा, इसका मास क्या है? 23 kg. इसका वेट क्या हो जाएगा? 23 into 9.81. What does your answer comes out to be? 23 into 9.81. Sorry, you will. Sorry. I switched into AS. Whenever you are doing IGCSE, you will always take the value of G as 9.8. यहाँ पे आपको weight निकालना है. What will you do? Weight is equals to mg. Mass क्या है? 23. G क्या है? 9.8. Can you calculate the weight? 23 into 9.8. The weight comes out to be what? 225 Newton. This is your weight of the soft iron bar. Calculate the distance D between the pivot and the joint holding the soft iron bar at A. You have to calculate this distance D. How will you do that? You will say anti-clockwise moment is equals to the clockwise moment. What were your clockwise moment? 102. बेटा anti-clockwise moment किस तरह निकालोगे? The weight is 225 Newton multiplied by the distance D. Okay. 225 into the distance D. Can you calculate distance D? 102 divided by 225. What does your distance D comes out to be? And the distance D comes out to be 0.45 meters is your distance D. Simple as that. Nothing complicated here. इतना आसान है physics. Perfect. Figure 7.2 shows a coil attached to a power supply placed below the soft iron bar A. ठीक है भाई, एक पावर सप्लाई है, उसके साथ एक coil लगा हुआ है below the soft iron bar A. State and explain what happens to the wooden barrier arm when the switch in the coil is closed. बेटा जब ये switch को हम close करेंगे तो what will happen? When the switch in the coil is closed, what will happen? This will cause the coil to get magnetized. This will cause the coil to get magnetized. What will happen? As the coil gets magnetized, the soft iron bar will be attracted towards the coil. As the soft iron bar gets attracted towards the coil, anti-clockwise moments increase. This entire wooden barrier arm will move towards the top side or the upside. So state and explain what happens to the wooden barrier arm when the switch in the coil is closed. So arm ko kya hoga? What will happen to the wooden barrier arm? The wooden barrier arm moves upward, or you can say rotates anti-clockwise. The wooden barrier arm moves upwards. And what will be the explanation for this? What will be the explanation for this? When the switch is closed, the coil becomes magnetized and it attracts. And it attracts what? It attracts the soft iron bar. When the switch is closed, it causes the coil to become magnetized and it attracts the soft iron bar. You can say, and it attracts the soft iron bar downwards, generating an anti-clockwise moment. Simple as that. The switch is opened. An operator decreases the potential difference across the coil. The switch is then closed. आपने क्या किया? स्विच को ओपन किया, देन द ऑपरेटर डिक्रीजेस द पोटेंशियल डिफरेंस अक्रॉस द कॉइल. मतलब आप क्या कर रहे हो? यहाँ पे जो पावर सप्लाई का पोटेंशियल डिफरेंस है उसको डिक्रीज कर रहे हो. देन यू आर क्लोजिंग द कॉइल अगेन. State and explain how the effect of the wooden barrier arm compares with the effect in B part 1. अच्छा जी, अब wooden barrier को क्या होगा? The wooden barrier will move up more slowly. Yeah, the wooden barrier moves up slowly. Why will that happen? Because the magnetic field strength of the coil decreases. You will say the wooden barrier arm moves slowly. And the reason being what? What will be the explanation? The magnetic field strength of the coil decreases. Simple as that, nothing complicated here. A student suggests that the soft iron bar A is replaced by a steel bar. Explain why a steel bar is less affected than the soft iron bar in the part A. बेटा स्टील बार जो है वो लेस इफेक्टिव क्यों है? बिकॉज द स्टील बार विल गेट परमानेंटली मैग्नेटाइज और जब आप स्विच ओपन भी कर दोगे व्हेन यू ओपन अप द स्विच द आयरन बार will not move upward. The iron bar will not move upward. It will stay attracted to the steel bar and the barrier will remain upward. देखो होगा क्या अगर यहाँ पे मैं स्टील बार लगा देता हूँ इफ आई प्लेस अ स्टील बार हेयर या आयरन बार स्टील बार से अट्रैक्टेड ही रहेगा even if I open up the switch and the wooden arm barrier will always remain to the top. So you can write it here. Why a steel bar is less affected. You will say the steel bar will get magnetized permanently, causing the soft iron bar to remain attracted even after the switch is open. Simple as that, nothing complicated here. Let's further move ahead. आगे बढ़ते हैं बेटा. An isotope of boron is used in the treatment of cancer in the brain. Boron sticks to the cancer cells in the brain. The isotope of boron is bombarded with neutrons and undergo fission to form lithium and alpha particles. Describe one difference between fission and fusion. Fission किसे कहते हैं बेटा? Splitting. Now I'm not writing the entire definition. I think we are already spending too much time on this paper. Fission किसे कहते हैं? Splitting of nuclei को. And fusion किसको कहते हैं बेटा? What do we mean by fusion? Combining of nuclei. Combining of nuclei. Simple as that. A nucleus of boron contains 5 protons. The proton number becomes 5. And 5 neutrons. Mass number क्या हो जाएगा? 10 plus 1 neutron. Complete the nuclide equation for this fission reaction. You have to complete the nuclide equation for this fission reaction. Alpha आ गया 4 2. Now, how will you calculate the mass number and proton number of lithium? Now, there is no need to remember that. You can say that the mass number of lithium is X, proton number of lithium is Y. You will say the sum of proton number on left hand side is equals to what? Sum of proton number on right hand side. लेफ्ट हैंड साइड पे क्या है भाई 5 + 0 राइट हैंड साइड पे क्या है y + 2 कैन यू कैलकुलेट y is equals to 5 - 2 that is 3 y किसके इक्वल आ गया 3 now we will do the same thing for the mass number sum of mass number on left hand side is equals to sum of mass number on the right hand side 10 plus 1 that is the mass number on the left hand side is equals to x plus 4 what does your value of x comes out to be 11 minus 4 this comes out to be 7 okay the alpha particles destroy the cancer cell suggest and explain one reason why the alpha particles are more suitable than gamma radiation for use in the treatment of brain cancer Like, why are alpha particles more suitable for the use in treatment of brain cancer? Alpha particles have a greater ionization power, have a greater ionization power. Yeah, ionization have a greater ionization effect. Hence, they can kill cancerous cells. Hence, they can kill या फिर destroy cancerous cells, whatever you want to say. Hence, they can kill cancerous cells easily. Let's further move ahead. Other cancers are treated with gamma radiation. Describe one safety precaution a nurse or radiologist takes during this treatment. Reduced exposure time. ठीक है, अगर आप गामा रेडिएशन से डील कर रहे हो, मेक श्योर यू आर reducing your exposure time to it. Figure 9.1 shows a diagram of a transverse wave. From figure 9.1, identify all the lengths that represent one wavelength. By crest से crest तक, this will be your wavelength, Q. What will be one more wavelength? Starting from here, ending here, this is one more wavelength. Q and V are your wavelength. Perfect. Hydrogen in a very distant galaxy emits electromagnetic radiation, which is observed on Earth. Scientists on the Earth measure the wavelength of the radiation from the very distant galaxy. The wavelength from the distant galaxy. ये wavelength है from the distant galaxy. That is 918 nanometer. On Earth, hydrogen in the laboratory emits electromagnetic radiation of 656 nanometer. This is the wavelength at Earth. Name the effect that the scientists observe and state what this shows about the very distant galaxy. The effect that the scientists are observing is redshift. What is happening with the galaxy? The galaxy is moving away from Earth. The galaxy is moving away from Earth. Galaxy is moving away from Earth. Simple. Let's further move ahead. आगे देखते हैं क्या लिखा हुआ है. Table 9.1 shows the wavelength of electromagnetic radiation from hydrogen observed in the laboratory and from three galaxies. The galaxy are at a different distance from the Earth. ठीक है. You have the hydrogen की wavelength in a laboratory, then from a nearby galaxy, then from a distant galaxy, then from a very distant galaxy. Simple as that. Describe what table 9.1 shows about the motion of the galaxies and state what this suggests is happening to the universe. चलिए क्या हो रहा है यूनिवर्स में and what is this wavelength suggest? The galaxies further away are receding with a higher redshift. That means galaxies जितना आपसे दूर हैं उनके पास ज्यादा redshift है. That means the universe is expanding. So you will say galaxies further away. I think this is the last question because we have already spent too much on this paper. Galaxies further away from the Earth have a greater redshift. Have a greater redshift, indicating that the universe is expanding. Indicating that the universe is expanding. Simple as that. Let's further move ahead. आगे बढ़ते हैं भी. Now, oh, we have one more question. Stars more massive than the Earth can form black holes. Yeah. Describe how a black hole can be formed from a more massive star. यहाँ पे किस चीज की बात हो रही है? Red super giant की बात हो रही है. Now, how is a black hole formed? How will you tell that? You will say most of the hydrogen gets converted into helium and then hydrogen runs out. Most of the hydrogen, most of the hydrogen in the core of a star, most of the hydrogen in the core of star gets converted into helium. And then what happens? And then hydrogen runs out. And then hydrogen runs out. What will happen further? And further क्या होगा भाई? What will further happen? The star expands and forms a red supergiant. बेटा फिर क्या होता है? What further happens? The red supergiant explodes. The red supergiant explodes, yeah, undergoes an explosion known as supernova. The red supergiant explodes as a supernova. The inner core of the red giant forms the black hole. The inner core of the supernova becomes a black hole. Easy peasy lemon squeezy. Let's further move ahead. The star V404 contains a black hole. The system is approximately 7,800 light years from the Earth. Describe what is meant by a light year. The distance traveled by light in 1 year. The distance traveled by light in 1 year. Traveled by light in 1 year. Calculate the approximate distance from V404 to the Earth in kilometers. The distance is 7,800 light years. अब एक light year कितने distance के equal होता है? The distance traveled by light in 1 year. What is 1 light year equal to? Let's calculate that. 1 light year is equal to the speed of light, that is 3 into 10 is the power of 8 into the time in 1 year, 365 into 24 into 60 into 60. What does this comes out to be? 3 into 10 is the power of 8 into 365 into 24 into 3600. 1 light year comes out to be 9.46, 10 raised to the power of 15 meters. एक light year कितना distance होता है? 9.46, 10 raised to the power of 15 meters. You have to calculate for 7,800 light years. 7,800 into 9.46, 10 raised to the power of 15. What does your answer comes out to be? This answer comes out to be 7.4 into 10 raised to the power of 19 meters. Can you convert it into kilometers? Divide by 1000. निकाल लो 7.4 10 raised to the power of 19 divided by 1000. The answer comes out to be 7.4 10 raised to the power of 16 kilometers is your answer. You can write here 7.4 10 raised to the power of 16 kilometer. I think the paper has finished. If you have any questions, you can ask in the comments below.